In this video, we will discuss about the basic scalar data types in Python. And first, let's have a look on the two types of data types which are important to be able to distinguish in Python, the so-called immutable data types and the so-called mutable data types. The immutable data types are those where if you create a certain object, a certain information, it cannot be changed after the creation anymore. That means if you want to change its content, you have to create a new instance, a new object with the changed content. And the examples which we will cover today, the bool, the integer, the float, the string, the tuple, and so on, they are all immutable. The other big group of the data types are the so-called mutable data types, and those are the data types where after the creation of the object of the data, you are still able to manipulate the data without creating a new one. And the list, the sets, and the dictionaries, which we will have a look at later, are examples for that. Why is it important to know the difference? Because for mutable data types, you have to be aware of so-called side effects. So basically the fact that you can change the data after it has created is causing some situations where you have to be careful to deal with them. So just remember those two names, and then we can go basically to the data types themselves, that are the ones which we will cover in this lecture. First of all, we are covering the integer numbers, which is just a number, the number you know from 1, 2, 3, 4, and so on. And basically these integer numbers, the range in Python which you can represent which integer number is arbitrary. So basically there is no upper limit for those numbers. However, you have to be careful because, of course, if you are using a machine like a 64-bit machine, which usually everybody uses nowadays, then there is a natural limit for the integer numbers. Basically, this is the natural limit of your processor, the biggest integer number your processor can deal with. In Python, you can go beyond this limit. There's no problem. However, you will pay for that by speed, because then the numbers have to be emulated by Python. We can just try it out. For example, we can just take here this cell and try it in Jupyter Lab. So basically you can just copy paste this small program into Jupyter Lab. We are starting with a number which is quite a high number, and we are doing nothing else, just making a loop, which we will discuss later in the next video, and we are multiplying this number by 2 at every iteration. So we are 63 times we are going through this loop and multiplying the number by 2. And here we are using a so-called Anaconda or Jupyter Magic or Conda Magic, and this basically, or Jupyter Kernel Magic commands, and this is basically there to say, okay, take this cell and repeat it 10 times and just measure the timing. And if you are executing this, then it will repeat this operation 10 times, and then you see that we have something like 25.3 microsecond per iteration. Now, if I am just taking the same example again, and that you can try it in your Jupyter Lab notebook, but I'm starting with a number of 1. So basically I'm starting from 2 to the power of 0, which is 1, and I'm executing this cell again 10 times. The time it does it in the background, and then you see that we are much faster. We are almost 1 order of magnitude faster. Because why? Because the numbers which I'm using in this loop I'm dealing with, they are all representable natively by the processor, so the operations are fast. Here the numbers which I use, they cannot be represented by the processor anymore, and it needs some complicated algorithms in order to deal with them nevertheless. So just keep in mind, integers, you can use arbitrary integers, but if you want to have fast integers, then you should stay basically in this realm of not going beyond 2 times 2 to the power of 63 on 64-bit machines, which you probably use. Okay, so let's have a look at the next data type. Is a so-called floating point data type, where we don't have integer number anymore, but floating points. The range which you can represent is 10 to the minus 300 till 10 to the plus 10 to the positive plus 300, right? So it's quite big, and we can use 16 digits. So basically, roughly the precision which we have in Python for the floating point numbers corresponds to 16 decimal digits. It's super important to remember that floating points are never exact, or almost never exact, when you use them in programming. And if you make operations with them, then the results are always approximative. This is something you always have to keep in mind, and we will discuss that later at later points also about that. There are different ways how you can represent floating point numbers, just the so-called fixed notation. So basically then the number, then the decimal dot, and then the fractional part of the number. Or you can use the so-called exponential notation, which means that you have a number, then e, and then an exponential, and that means that this number which is written here times 10 to the power which is written here, right? Whether you are using a capital A or a small a, it doesn't really matter. And of course, if the number is way too big, then it can even lead to infinity. And if then that number is way too small, then of course what you get is 0, right? So if you go beyond the range in the negative or the positive exponent. Python has also complex numbers, which is quite nice for us for many purposes. And the complex numbers are written basically as a combination of two real or two floating point numbers. The real part of the complex number plus the imaginary part of the complex number, and the imaginary part must be here followed up with a j suffix. So basically j means that this is the complex part or the imaginary part of the number, right? If you have number, you can of course combine them using various operations, and those are the operations which you know already, the plus, minus, and so on and so on. Maybe the only interesting one is the division, because that behaves Python differently from other programming languages, and this is something we can also test it. So here, if we are dividing 5 by 2, so this is what I wanted to do. If I'm dividing 5 by 2 and execute it, then I get 2.5. So I was starting with a data type integer. 5 is an integer, 2 is an integer. I was dividing them, but the result which I get is a floating point number, because this is exactly the result of this division. This is very nice and very intuitive. But this is not how it works in other programming languages. In many programming languages, if you are dividing two integers, the result is also integer. And in Python, you can emulate that with the integer division. So basically, if you are using 2 slashes instead of 1, then that means that you are dividing this number and you are throwing away the fractional rest, but you get only the integer part of the results. Okay. Otherwise, everything else is, I think, quite easy. This is here the remainder here, so you can get the remainder of the division of the 5 by 2. Then, of course, the remainder is 1, and so on and so on. And the power operator, if you want to take a number to a certain power, then you have to use the sign star operator. Okay. You can also compare numbers with each other, various numbers with each other, with the so-called relation operators. So basically equal, you check whether two numbers are exactly equal. Bang equal means that they are not equal, unequal, less than greater, less, greater equal, and less equal, right? Of course, you have to be careful that you are only comparing numbers which are comparable. So for example, you can easily also compare whether two complex numbers are identical or where they are not equal to each other. However, what you cannot compare whether they are whether a complex number is less or bigger than another complex number, because of course there's no ordering for the complex numbers, so that will definitely not work. Okay. When you compare two numbers, as you can see here, you get some results which it says either false if it's not the case, or true if it is the case, and those are so-called logical values, so-called bool values. And these bool values can also combine using logical operators. One thing to keep in mind, that this true is actually, this logical true, this bool value is actually a number in Python, and also false is a number. So you can even make something like this, but you should not do actually to say 2 times true, because true is represented usually in Python by the integer 1 and false by the integer 0, but you should never use that. What can you do with logical values? Otherwise, you can combine them using logical operators like the AND operator. This would give you true if both of the logical operators operands are true, or with the logical OR, which would give you true if any of them is at least one of them is true. Or you can apply the NOT operator, which would just turn the value of the logic. So if it's true, it would become false. Okay. Of course, having values is a nice thing, but sometimes you want to would like to, with an object, associate a name, and this is the concept of the variables in Python, variable assignment in Python. And I would like to discuss a little bit what happens here in this assignment when you say a equal 1, because this differs a bit how that it works in other languages. Although you won't see any effects for the immutable data types, but you will see very, very important effects for mutable data types. So let's have a look. What does it mean a equal 1? What does it mean in Python? It means that in the memory there is an object created which contains the integer number 1, and then a name a is created, and the name a just points to this object in the memory, right? Okay. So if you are using the name a, then always the object it points to will be substituted. What happens if you are now doing b equal a? So basically you are assigning the value, the variable a to the variable b. That means that basically here a was pointing to the object 1 in the memory, and also b will now point to the same object in memory. So this is what means b is equal 1. If you now make a new assignment, you are saying a is equal to, what will happen? There will be a new object created in the memory which contains the integer number 2, and the name a will be associated with that object in the memory. And always when you are using a or b, they will always substitute it by the corresponding object in the memory to which they point to. And of course, you can also combine them. It is very important to note that basically this variable assignment are not really variable assignment in the classical sense, where you may or you might know it from other programming languages, but basically they are just pointers. So basically the a equal 1 means that the pointer with the name a or the name a points to an object which contains the 1 in the memory. Okay. The last data type I would like to cover today are strings. Strings are basically just a container for characters, so an ordered list or ordered set of characters. And basically strings are specified by apostrophes or quotation signs, and basically in between you can write the content of the string, and then if you visualize them you get basically the content back. If you want to know the length of a string, then you are using the len function, which gives you the number of characters in the string, right? So name 1, which was John, which contained 4 characters. If you are evaluating len name 1, you get exactly here the value 4. If you have a long string, like here, where you have basically multiple lines, then you should open your string with 3 consecutive quotation signs, and then you can make here new lines, and then the string, if you give out the string, it will contain both lines, and you see it here in the middle of the 2 lines. It's that they are joined by a special character. This is this \n character, which represents the new line character. So that means, okay, if I would print it, there would be a line break, a new line after the first line. Okay. For strings, as I said, this is a container of characters. That means this is an ordered set of characters, and you can also access each character individually if you want. For example, if you define the variable txt with the content some text, and you want to access the first character in this string, then you can just ask, okay, give me txt 0. Don't forget, as in Python, always we start counting with 0. So the 0th character is s. You can get also a range of characters. So basically you can say, give me the first 4 characters of the string. Here you are specifying the first character you want to see, here the last character you want to see. And you remember maybe from other Python courses already, the upper limit in Python is always exclusive and the lower limit is always inclusive. So basically, if I'm saying give me the characters from 0 to 4, that means it will give me the character 0, the character 1, the character 2, and the character 3. So 4 characters all together, right? Exactly as it's written here. You can also say, okay, give me all characters from 0 to 9, where 9 is exclusive, but in steps of 2. That means it will give me every second character in this range. If I'm not specifying the lower limit, I'm leaving it away, then it's automatically 0. So basically, if I just say txt and then colon 4, that means give me all characters from 0 to 4. So this is exactly equivalent to that what I have written here. Similarly, if I'm leaving away the upper limit like here, so I'm saying, okay, give me all characters starting with 4 up to, and I'm not specifying the upper range, that means that it will give me all characters until the end of the string. And it's even possible to revert a string by basically giving making a step size which is negative and giving a starting and an end index, the starting index which is higher than the end index, and if the step size is -1, then it will start from the 8th character, going back to the 4th, but not including the 4th in steps of -1, and then that would give me exactly 4 characters, but in a backwards way. And if I'm giving a character range which doesn't contain anything like 3 colon 3, that means give me the character starting from the 3rd up to but excluding the 3rd one, and that means that the interval is completely empty, then you will just get back the empty string as a result. As I discussed or I mentioned before, there are immutable data types in Python, and also the strings. The string data type is an immutable data type. So I can access the 0th character of the string, but I cannot change it. So I cannot say, okay, set the 0th character of the string to a value b, right? And then say, okay, Python will say that the type error that string does not support an item assignment. So strings are immutable. You cannot change the content of a string. You can always create a new string by combining strings together, but you cannot change their content. How can you combine strings together? The one possibility is, for example, adding strings together. Adding strings means concatenating their content. So here, for example, I'm just adding name1 plus and then a string with an empty, with a space in between the quotations, and then plus name2, and the resulting object is a new string which contains the first string, a space character, and the second string. Actually, in Python, it is even possible to concatenate strings without any operators. If you just have 2 strings next to each other, they will be automatically concatenated. Sometimes you can use it quite nicely to format code when you have a lot of output. Strings can be repeated. That would be the multiplication operator. If you say take the string AB and multiply it by 3, that would mean that you would get the string AB, AB, AB as shown here, right? So you would get the same string 3 times. Okay. With strings, you can also do very, very nice formatting, and this is something you should play around with that. And this is the so-called formatted strings or F strings, and F strings are basically shown or indicated that before you have the quotation sign, you have an F, a letter F, and then this is called F string, a formatted string. What is the nice thing with this formatted string? Let's assume that you are declaring a variable A and a variable B, so that they have both certain values. And now you want to print out that this string here. So A is equal the actual value of A, and B is equal the actual value of B. Then what you can do is to say, okay, I have a string here. Print here the characters A and equal. And then please substitute in the string the actual value of the variable AA, right? And then add the characters, the comma, the space, B and equal, and then again substitute the actual value of the variable B. And basically in f strings, if you have something in curly braces, then the expression inside the curly braces will be evaluated. In this case, the variable a, or in this case, the variable b. And then when it's evaluated, the result is added into the string, and then the resulting string will be a string which contains basically the string representation of the executed expressions. You can also tell Python how to format those things. So basically you can say, okay, just print a with a width of three characters and as an integer. We will discuss this in a second what this d exactly means, but basically you can add formatting information. Here also it says, okay, evaluate here the expression b and then apply formatting. The field width should be 3 and the data type should be integer. D is an integer data type. And what I did also here, I also added \n. That means that it means that, okay, also add a new line character. What is the result? I get here the string a equal, and then I get basically here the number 12, where the number 12 is written with a field width of 3 characters. And because I say that it's an integer, this d indicates it's an integer expression, it's right aligned. The same here, the b equal is printed, and then the integer, the current value is 135 is printed, and again right aligned. Of course, it's super important that you are choosing the right kind of data type. For example, if you have a variable c which contains a floating point number, then trying to print it with the help of an expression where you declare it as an integer expression, of course this will not work. So the data type and the expression must match. The options you can specify are very different. There is a lot of them, and I'm definitely not showing you all of them here. If you want to look it up, you can consult this format specification mini language of the Python of the Python website. And here you can basically look up what kind of options there are and how you can use them in order to make nicely formatted output. The most important we will deal with integers. When you write a d, a fixed floating point number with f, an e for an exponential notation with a small e as a separator, or with capital E as a separator. And maybe for you it could be interesting to have the G formatter, which is a nice thing, which basically changes between fixed and exponential notation depending on the value. So basically here the W here it's an parameter, an optional parameter which can be the field width. So here you can have a look at this example where I declare the variable f to the value of 1.2, and then I say, okay, create a string, an f string basically, by evaluating the actual value of f and formatting it in an exponential notation with a field width of 12 and with a precision of 4. Because as written here, if you are using the exponential format option, then you can also specify after the width of the field also an optional precision. That means how many digits should be shown. And here I say that I want to see 4 digits as exactly is written here, and a field width of 12 character altogether. The 12 character is basically here everything between the apostrophes. So basically into these 12 characters, also the e character and the sign of the exponential, also it's part of this 12 character, right? I can leave away, if I want, I can leave away the number of digits. That's no problem. Then I can just say, okay, I want to have a field width, but I don't care about the number of digits. Python should take the default one. Then you get the default number of digits. I can also say I don't care about the field width. Actually, the only thing I care about is that I want to see exactly 4 digits after the dot. Then I can just say dot 3, and so on and so on. And here I also show that you can also have a string formatting if you really want, and then you can say, okay, I want to have a field width and just string formatting, but strings are left, as you can see, strings are in contrast to numbers, which are always right aligned, strings are left aligned. Anyway, this is something you can play around with a lot, and I really recommend you to have a look on the format specification mini language if you want to explore further options. There are only a few things I would like to show you, a few remarks on this string formatting. And basically one thing is that if you set the field width incorrectly to be too small, then basically what will happen is, so basically here we are creating an f string with a bar character. Then we are evaluating the actual value of this expression of the variable num, which is 123. And we want to print it with a field width of 1. And of course it's not possible because this number has 3 digits, and you see that Python would, without giving you any warning or any problems, it would just adapt the field width to the minimal necessary one. The other thing which is interesting is because how you can print the character curly brace itself, because of course in the macro, in these f strings, this curly brace has a special meaning. It means, okay, I'm now giving you an expression which must be evaluated. If you really want to say Python, no, I'm using curly brace because I want to really see the curly brace character, then you have to make it double. So here I make a double opening curly brace, which would create the curly brace character, and then I have a curly brace and an expression in between to tell Python, yes, please evaluate here evaluate the expression which I have, and then I have here a double curly brace to close it. Okay, and here I have already a mistake, as you can see, because here I should have written num. And why did I write here 0? Because there's also another way, an older way, but sometimes more handy way of formatting strings in Python. And that is that you are specifying not an f string, but a normal string with the usual specification, what we use in f strings. And then you are calling the so-called format method of the string, like here. And then you are passing here basically the options, the variables, the expressions you want to see that substituted here, right? But why is that useful? This is useful, for example, if you want to have access to various different parameters, different times, because then within the when you use this format kind of string formatting, then instead of writing the name of the variables, which you cannot do, you can use numbers, and these numbers are referring to the order of the expressions which you are specifying here. So for example, if I want to print number 1, then number 2, then number 1 again, then I could say, okay, first give me the 0th of the arguments. We are starting counting from 0 in Python. Then give me the first argument, and then give me the 0th argument again. And the 0th argument is num1, and the first argument is num2, and then it would do it accordingly, right? So that should be okay. Good. The last thing which I would like to discuss here is how you can convert data types into each other. And that's very, very straightforward in Python. So basically every data type which we have learned until now has a converter function, the integers, the ints, the converter function int, the floating point numbers, the conversion function float, the complex numbers, the conversion function complex, and the string, of course, the string. And basically inside those functions, you can write any kind of argument you wish, and if it can be converted to the data type, it will be converted. For example, if you want to convert 3.2, the floating point number 3.2 to an integer, then it's possible, and you will get the integer 3. Of course, the fractional part of the number will be just thrown away. It also works with string. If you want to if you want to convert a string into, let's say, a floating point number or an integer, then you can also specify a string as an argument. So that also works even for complex numbers, as you can see. Of course, it can be only carried off that the string really represents a complex number or a floating point number. And for example, if you specify here a variable which contains just a string 3, then, and if you contain it to integer, then indeed you get the variable 3. But if you try to feed a string into the int function which does not represent a number, then of course you will get an error, exception, an error, so this will definitely not work. With that, I will finish the part on the basic data types.